So as an example of this, right, let's consider this function, 1 over this quadratic. Let's find the domain of this. Again, to pull that off, we want to know where this denominator is 0. That's what we have to figure out. We want to know where the denominator is 0. Okay, so what do? The denominator is this quadratic, so we're solving this equation. Now this one, you could use the quadratic formula. This one's actually pretty easy to factor, right? You want, since the leading coefficient is 1, it's degree 2, there's only 3 terms. We're using a special case of that AC method, right? 2 numbers whose product is 1, whose, sum is 2. Product is 1, sum is 2. So you want 2 numbers whose product is 1, but the sum is 2. Well, how about 1 in itself? That works. So this becomes x plus 1 times x plus 1, which is really x plus 1 squared. And then you set each factor equal to 0. Although in this case, the only factor is x plus 1. So you would set that to be 0. And you solve for x. That's easy, right? You just subtract 1, you get x is negative 1. So the domain of this is all x except this. Except x equal to negative 1. That's what the domain is. So again, we determined where the domain was, where the denominator, was 0, and the domain is then everything else. Here's another one. In this case, we want to find the domain of this. Well, that denominator, okay, well, we want to know when x squared plus 4 is 0. Now, how do I say this? Oh, I mean, you could dive right into the quadratic formula, but you can also do this. Recall the discriminant of a quadratic is this. It's basically the radicand, what's under the radical in the quadratic formula. Now, it turns out this is actually never going to be 0. It has a negative discriminant. That's what I'm saying here. You can't factor it. That is, this has no solutions. Because this discriminant, as you can see, would be negative. I mean, if you also were to try and solve this equation using the quadratic formula, in the square root, you would have the square root of negative 16, which tells you this has no real solutions. So this is never 0. I mean, you could confirm that just looking at the discriminant, but you really could just dive right into the quadratic formula. And you'll see this has no solution. So because of that, this here is defined everywhere. So the domain for this is all real numbers. Any questions on that? So because it's irreducible, meaning you can't factor this, sorry, let me say it this way. Because the discriminant is negative, this has no solutions, no real solutions. Okay? Let me just take this out. Better. So the discriminant's negative, that's better. Okay. Now, these kind of examples I wanted to do because, at least from my experience teaching this class virtually, or maybe in class, I don't remember, but people generally have trouble calculating these. So I figured it wouldn't hurt to go through this. So let's say f of x was this polynomial, okay? Let's calculate f of negative 2 and f of 3. Then we can use those solutions to get this sum. Well, how do you get f of negative 2? all you're doing is you're replacing x here with -2, as I'm doing. So f of x, whatever x is x squared plus 4 times x minus 7. F of -2 then is -2 squared plus 4 times -2 minus 7. And this becomes 4 minus 8 minus 7, which is minus 4 minus 7, which is minus 11. F of 3 is the same idea. You're replacing x but with 3. So we have 3 squared plus 4 times 3 minus 7, which is 9 plus 12 minus 7, which turns out to be 14. 21 minus 7, which is 14. Okay, so what is the sum? Well, f of -2 we got is minus 11. F of 3 we got is 14. This sum is minus 11 plus 14, which is 3. That's what we get. Okay. Moving on. For this one, same idea. Let's get f of 1 and f of 5. And then we're going to find their difference. So what's f of 1? Well, you replace x by 1. That's what I'm doing, right? We have minus 1 squared plus 1, which is minus 1 plus 1, which is 0. F of 5 is minus 5 squared plus 5. Okay, this becomes minus 25 plus 5, which is minus 20. So the difference here is 0 minus minus 20, which is 20. And I just wrote this as a reminder. I think I said this earlier in the course, but minus x squared is minus 1 times x squared. It's not the same as this, is what I'm saying. You got to be careful with the negatives. All right, this one I was going to let everyone try. So, take like let's just do it together. Mostly because I want to get to the worksheet I have that I emailed. So for this one, we have f of 2 and f of minus 3. Okay, so then you calculate the sum. It's the same thing, right? You have f of 2. You just replace x by 2 in this. So we have 4 times 2 cubed plus 2 times 2 squared plus 2 minus 1, which is this. F of minus 3, 4 times minus 3 cubed, right? And replacing x by negative 3 plus 4 times minus 3 squared plus minus 3 minus 1. And you can see that becomes, by direct calculation, minus 94. So the sum is 41 plus negative 94, which is 41 minus 94, which is minus 53. Any questions on these? All right, let's do the worksheet now. So let me stop. So the worksheet I'm going to share. Let me do that. If I can, is it open? No, it's not. Here we go. I did email it as well. So for the first one, you're basically determining if these 3 equations define y as a function of x. And really the best way to do it is, I would just sketch the graph in Desmos. And then you have to write y as a function of x. You do the same thing for these 3. You're just finding the domain. So that's all you're doing here. Okay. So I want everyone to work on that for about like 5 or between 5 and 10 minutes. Then we'll go through as much as we can. Worst case is I just post solutions to it. So I do have the solutions anyway. So let me stop the recording.